Good evening, everyone, and welcome to today's lecture. This is lecture number 4 in electric field, and we are dealing with electric field due to continuous charges. And in the previous class, we had seen the electric field due to line charge. Do we remember this? We had seen the formula, and then I had given you a question to solve. This was the question. We had minus lambda, minus 3 lambda, 2 lambda, and 4 lambda charges. And we had to find out the electric field due to this distribution at the center of the square. Anyone got any answer for this? Anyone got any answer for this? How are we supposed to do this? Anyone? No one?
Sir,
Yes, beta.
23 lambda by 2 root 2 epsilon naught r.
Are you telling me the magnitude?
Yes, sir.
Which direction it is? Any idea about the direction? 23 is not possible. An odd number is not possible here, probably. It would be probably an even number. No. Okay, 1 is 3, 1 is 4. Yeah, odd number might be possible. How are we supposed to do this? I'll just tell you how to find out the field due to 1, and the rest of them you can do. So what you do basically is, let me say that if I have to find out the field due to this charge, this minus lambda, I know both of these angles are 45 and 45 each, yes or no? So let me say this electric field is E1. The value of this E1 would be equal to lambda by 4 pi epsilon naught r. The y component will cancel and the x component will be added up. Both the angles are 45 and 45. Sine 45 plus sine 45 is 2 times of sine 45. Yes or no? And the direction will be along minus I. It will be towards this charge. Everyone understands this? If
Yes.
I write this electric field in the vector form, we understand this?
Sir.
Yes or no?
Yes, sir.
This charge is, this is not minus lambda. I think this is plus lambda. Minus is coming because of my drawing this line. So let me take off this line. It is not minus lambda. I think it is plus lambda. So the line is like this. Okay. It's not minus lambda. It is plus lambda. So it will be along plus I. It will be going like this. Now, if I find the electric field due to the second one, it will be 2 lambda by 4 pi epsilon naught. Remember, this r is the distance between the point and this r here will be equal to a by 2, the length divided by 2. Do we understand this? So
Sir.
instead of this r, I must write, and these are the simple things that we might make a mistake. For in place of this r, we must write L by 2. Do we understand this?
Yes, sir.
Okay. Similarly, for this, it will be L by 2. So again, 1, 2 will come, and this will be equal to 2 times of sine 45. And this would be also along plus I. So similarly, you can write the formula for everyone. Remember, the field due to this charge will be along this direction. The field due to this charge will be along this direction. They will get added up. You will get electric field along I and J. You can square them and add them together and take the root. You will get the magnitude of electric field. Do we understand this? Yes or no?
Yes, sir.
Everyone got this? How I have done this?
Yes, sir.
Now, if you make this line charge as infinite, so if you make this line charge as infinite, and this is the electric field due to an infinite charge, now what happens when this line charge becomes infinite? in this case, the y components will cancel each other out and you will be only left with the x components, and your answer will be lambda by 4 pi epsilon naught r into sine 90 plus sine 90. Sine 90 plus sine 90 is 2. So your final answer will be lambda, oops, wrong color, lambda by 2 pi epsilon naught r. Everyone knows this, yes or no? For a infinite wire, this will be the magnitude of electric field. Do we know this, yes or no? Huh?
Yes, sir.
This will be the electric field due to a infinite wire. And if I ask you what will be the graph of this electric field like, so here you have the graph of this electric field. So this is electric field due to a infinite wire. Electric field due to a infinite wire. I hope you understand how it is drawn. Electric field due to a infinite wire. We understand this, yes or no? Huh?
Yes, sir.
Yes,
What
sir.
would be the direction of this electric field? So remember, if this line charge is having positive charge, the electric field will go away, whether you take it this side or whether you take it this side also it will go away. Electric field lines always go away from a positive charge and always come towards a negative charge. I hope all of us remember this, yes or no?
Yes, sir.
Everyone understands this? I'll give you a minute to note this down. Note this down and let me know once you are done. If you have noted it down before, you can just check the answers, nothing else. If you have noted it down before,
No, sir.
okay, not a problem. Note it down now.
Completed, sir.
Everyone done, boys?
Yep.
Done?
Yes, sir.
Okay. Now, what will be the electric field due to a semi-infinite wire? Now, very rarely you will get the electric field due to a semi-infinite wire, because most of the cases, this is asked only in case of magnetic field, but you never know what can happen in a JEE advance. Anything can happen. Probably this will not come in JEE Mains, but this is a stuff of JEE advance. Now, what do I mean by a semi-infinite wire? When I say a semi-infinite wire, let us say that this is positively charged. You have one end here, so it starts from here and it does not end on the other side. This is known as a semi-infinite wire. I've seen questions based on this. They ask you in JEE Advanced to find out the flux due to this thing or something like that. It has two components, as you can see, because the components are not going to get cancelled, EX and EY. Remember, both this EX and EY component are equal. Can you tell me the value of this EX and EY? Huh? What is the
Lambda by 4 pi epsilon r, sir.
Great. Both of them are equal. They are same. You can call any one of them as lambda by 4 pi epsilon naught r. If you don't want to call it this way, you can call it k lambda by r. You can easily call it k lambda by r. Doesn't matter. Do we understand this, yes or no? This was electric field due to a semi-infinite wire. Do we understand this, yes or no?
Yes, sir.
Yes, sir.
Now, how are we going to do this, or how are we going to face questions on this? This is an example of one of the questions, again taken, I think, from your module. So, what do you have here? You have a point charge q is placed at a distance r from a very long, infinite line charge of density lambda. Find out the total electric force experienced by the line charge due to the point charge. You have 2 minutes to do this. Again, remember, JEE, whether I talk about JEE Main or I talk about JEE Advanced, both of them are a test. JEE Main 100% of your speed, JEE Advanced 70, 80, 90% of your speed. If you can do things quickly, that is what that is going to matter in the end.
Lambda by 2 pi epsilon naught r.
Lambda by,
2 pi epsilon naught r.
that is not the force. That is electric field. I've asked you the force. I've asked you what is the force between the two, between the line charge and the point charge. You are telling me the electric field. That is half of the answer.
Lambda q by 2 pi epsilon naught r.
Yes, beta?
Lambda q by 2 pi epsilon naught r.
Lambda q by 2 pi epsilon naught r. That is correct. So it would be difficult for you to find out the force on force due to charge on the line, but it is very simple for us to find out the force due to line charge on the body. Yes or no? It is easier because you know the electric field due to the line charge, and I will just show you the diagram. You can easily find the electric field due to the line charge. We have already calculated it. We know the value of electric field. So you can do this question in the reverse way. Remember, by Newton's third law of motion, whatever force the point charge exerts on the line charge must exert the same force on the point charge. We know the electric field at this point is E, and this E is lambda by 2 pi epsilon naught r. Why is this happening? Because of this. Lambda by 2 pi epsilon naught r is the value of electric field. You just find out the force, you multiply this Q by E, and you end up with your answer. So Q times lambda by 2 pi epsilon naught is the answer. Do we understand this, or this has gone up our head saying bye bye?
Understood, sir.
Don't worry about me. I'm going. Everyone understands this?
Yes, sir.
Now, this is a question that I've seen in one of the JEE. Let's see if you can do this, because these are the type of question that can come. Now, this question could be put in various ways. This is one variation of the question. Now, what they do is they are going to mix up your two topics together. So with electrostatics, they can mix up work, power, and energy. And with electrostatics, they can mix up this SHM. But I think your SHM is still not done. So once that SHM would be done, then we will come back and solve this problem. So we are not going to do it now. We are going to do it after you are done with your simple harmonic motion. So we'll come back and we'll try to do a couple of problems when you are done with it. We'll try to do a couple of problems based on simple harmonic motion and electrostatics, how they come together and go about. Okay, so we'll do it afterwards. Just remind me once you are done with your SHM, just remind me, sir, we have to do that problem of SHM in electrostatics. Okay.
Okay, sir.
Meanwhile, we can move ahead and move on to the next type of charge distribution, and the next type of charge distribution is your famous ring, a ring of charge Q plus Q. Let us say radius R. You have to find out the electric field at the point P, and I know everyone knows how to find it out. I'm not worried about how you can find it out or not. I'm more worried whether you know the end result. What is the end result of this one? Huh?
KQX by R plus X whole power 3/2, sir.
KQX upon R square plus X square raised to the power 3/2. That means electric field at the center O is how much? Huh?
0, sir.
How much? 0.
0, sir.
0, sir. We remember, sir. We understand that, sir. But, sir, tell me, sir, what about the graph of this thing, sir? Any idea about the graph? How does the graph of this thing look like? Huh? Graph. And they are what? They are more likely to ask you the graph. Okay, let us take first things first. What is the direction of electric field at point P? I am taking it as a positive charge. So can you tell me what is the direction of electric field at point P before going any further? What is the direction of electric field, my dear friends? At point P? No answers.
Cap direction, sir.
What direction?
SI cap.
I cap. Okay, so it will be going away in this direction. If this point P would have been here, let us say P dash, then if the point P was on the other side, bacha, then Arey? So difficult. If the point P,
direction.
that means if that direction is plus K, this direction would be minus K. Yes or no?
Yes, sir.
Okay, so it will go along minus K. Chalo, we know this. At which point, and I've seen this question in a JEE, at which point is the electric field maximum? How do you do it? At which point is the electric field maximum? Do you know it? Yes or no? No or yes? At which point is the electric field maximum? Say. No one knows this. If you know this, tell me, sir, we know. If you don't know this, tell me, sir, we don't know. There's nothing. I don't know everything in the universe. So if someone talks about quantum theory, I will just look at, okay, I don't know anything about this. Please tell me.
Sir, X is equal to R.
X equal to R? We are not playing Kaun Banega Crorepati here. So we cannot guess. Either we know it or we don't know it. I think you don't know it. Oops, what has happened here? Something wrong has happened. Wrong things are bad things. So let me make it good thing. This is the graph. You will draw it and keep it with you. And you can see everything is clear from this graph. At this point, this is the center of the circle. The electric field is 0. Then the electric field increases. It becomes maximum at this point r by 2. R by 2 nahi, r by root 2. And how do I get this electric field maximum? There is no hidden agenda here. You just differentiate this electric field. Which electric field? This is the electric field as a function of x. You just differentiate it, equate it to 0, do dung 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 dung, and you get the value of distance as r by 2. You may also know that the value of this electric field is this much, 2kq by 3 root 3 r square. Draw this graph, keep it in a safe place where you can take it out and uses this is electric field due to a full ring. Do you understand this, or this is going about saying bye bye, bye bye, I'm going, don't worry about me.
Understood, sir.
Remember this, all these points, remember, no one is going to ask you how it is derived. That is not something that anyone will ask. But what they can definitely ask is where it is maximum and what is the maximum value. Have we noted it down, bacha?
Yes, sir.
Then comes the next one. What is the next one? This one. And I'm giving you all this. Electric field due to arc of a circle. Electric field due to arc of a circle. So here I have a positively charged arc of a circle. Is it not the complete circle? It is just an arc of a circle. Lambda, charge per unit length is lambda. Anyone knows the answer for this? The total angle is theta. It's not 0, it is theta. Total angle is theta. Hey, you know it, it's good. It's just a revision then. You know it is good.
Lambda by 2 pi epsilon naught r.
Sine theta by 2.
Yes. Electric field is lambda by 2 pi epsilon naught r into sine of theta by 2. That is correct. Good. If you remember it, it's good. If you don't remember it, don't worry. We are doing it. Okay. So far, so good. Huh? Shall we move ahead in life? Life has to move on. Then we have this gentleman. Which gentleman? This one. The brother of ring. What is the brother of ring? Disk. That is the next one. Note it down. Electric field due to a disk. Disk has a charge on the surface. The surface charge density is given as sigma. Distance is x, and this is known as the semi-cone angle or vertex angle or whatever it is called. What? What is the electric field due to this gentleman?
Lambda by 2 epsilon naught of 1 minus x by root over x square plus r square.
Oops, you have gone so fast. I was not able to comprehend anything that you said. Can you please say again? Yes, bacha, say it again.
Lambda by 2 epsilon naught.
Sigma.
Sigma
Sigma by
2 epsilon naught of 1 minus x by root over x plus r square.
it's better to write it as cos theta. So that will be easier for you to remember. 1 minus cos theta. Sigma by 2 epsilon naught, 1 minus cos theta. Easier to remember. You can easily find the value of cos theta. Yes or no? No, yes.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. Graph. See, I'm giving you everything, every damn thing that they ever ask, or every damn thing that they can ever ask in any exam. This is how the graph looks like. So if they give you a graph in the exam, don't get bamboozled because you already know the graph. Then they are not going to ask you to draw the graph. They'll give you 4 or 5 graphs, and then you have to calculate, okay, where is this, where is that. Once you've seen the graph once, I think you will be able to collect that graph and solve whatever questions they put. Yes or no? So that is the reason I'm showing you all these graphs. So that if the question comes, you are ready beforehand.
Done, sir.
I'm looking for a question. Let me see if I can get it. Where is that? 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 Yeah, this one. Remember, they are more what? More inclined to ask you questions which just require some. And there was a point of time where they were giving a lot of question on this hold things. So this is one of the question. If you can do this, nothing like it. Calculate the electric field at a point on the axis, which is the distance x from the center of a uniformly charged disk having surface charge density sigma, radius r, which also contains a hole of radius small r. So basically, this is a disk with a hole. And these questions are very popular. I've seen a lot of questions in JEE Advanced where there's a disk with a hole and they put a point charge somewhere and then they ask you with what velocity this point charge is going to go on that side. Once you understand how it is done, the question is pretty damn simple. How are you going to do this? If you want, I can show you a diagram also. If you want, diagram is actually not required, but can show you that diagram as well. Have you done this question before? Oops. Disk with a hole. Disk with a hole, and I can also create a hole, a circular hole in a infinite sheet, which we'll be doing. Don't worry about that. How do you get the electric field? The actual question may not be the electric field. The actual question may be something else. The actual question may be something else. This is just to understand how you are going to calculate the electric field of this gentleman. I'll give you 1 minute to do this. Now remember, in most of the cases, what happens is we do the derivation of things. I mean, I could spend 15 minutes in deriving the uniform electric field created by a disk. That is only done so that if a question comes, should be able to derive it. But remember the trend in these days, you are not going to get a question directly on derivation. No one asks you this question. What they are going to ask is a question based on that. Now you must know how to, even if I have not told you how you are going to derive, if I tell you how you are going to derive, even that will not make sense, because if you do a simple mistake of plus or minus, the entire derivation is gone, and your entire hard work will be gone. Simple mistake of plus minus and we are done. So instead of understanding how the derivation is done, you just know the brief outline. If required, in a dire circumstance, you should be able to derive it. But if you understand the logic behind it, you can do a question which does not require the derivation. You can just use some common sense and you can get away with it. Not get away with it, can get the question solved with this. Any idea how this is going to be done? Forget about it. If you don't have any idea, unless and until you get this idea, you will not be able to do it. So how are you going to do this? Now remember, remember? Whenever you get a question on this hold things, you might get some questions. Now this question could be asked in the center of mass wala chapter. You might have a disk with a hole, and you have to find the center of mass of the remaining disk. This question might also come in moment of inertia, where you have a disk or a sphere with a hole, and you are supposed to find out the moment of inertia of that sphere. Have you done moment of inertia? Yes or no?
Yes, sir.
Okay. Have you found out the moment of inertia of a sphere with a hole?
Yes, sir.
That's it. That's how you do it. So that is the hint. How did you do it? How did you do it? So basically what I'm going to do the same thing. I'm going to imagine that there is no hole here and this entire disk is intact. And this has a surface charge density of plus sigma. Now, if this entire disk is intact, I know the electric field at the point P. What is the electric field at the point P? You just told me the answer. What is the electric field at point P? Huh?
Sigma by 2 epsilon naught
Huh?
into 1 minus cos.
Say the entire thing now. So electric field, let me call this as E1, and I will so it will be sigma by 2 epsilon naught. Tell me answer. 1 minus
Cos theta.
cos theta. What is the value? Because here theta is not given. So tell me the value of cos theta. What was the value of cos theta? X upon under root of x square plus
R square.
r square. Now, how do I create a disk? How do I create a hole? Actually, I don't need to create a hole. Basically, what I need to understand is I have to imagine how that disk with a hole is going to behave. So this with a hole is going to behave in such a way that there is no charge present in that space. Now, how do I cancel out that charge in that space? I can superimpose a negative disk of a negative charge minus q here, or minus sigma here. Now the original electric field, as you know, is going in this direction. Yes or no? Because it is the electric field produced by a positive charge. Do you understand this, or this is going above and saying bye bye?
Understood, sir.
So this negative sigma or negative disk will create an electric field in the opposite direction. And what will be the value? Now it is again a full disk. What is the electric field created by the second disk? Oh, it's wrong color. What is the electric field created by the second disk? Tell me. Look.
Sigma by 2 epsilon naught of 1 minus x by root over x square plus small r square.
Well, then you have the answer, my dear friends. This field is 1 minus x upon under root of x square plus r square. But this, my dear friends, is going in this direction. You add both of them vectorly and you got your answer. Do you understand this?
Yes, sir.
That's your answer. So what's your answer? You have to add them vectorly. One is going in this direction, the other one is coming in this direction. You have to add them vectorly. So what is the answer? And if I just copy paste the answer from the sheet, oops. I can't do that. Okay, I have to do it here. If I copy paste the answer from the sheet, this is the answer that is given, and I hope you are getting it. This is the answer that is there. Yes or no?
Yes, sir.
So that is how you do it. You do it. I call it the concept of negative mass. You can call it anything. Negative mass, negative charge, doesn't matter as long as you understand it. So far, so good. Shall we move ahead? In life, life has to move on.
Yes, sir.
Okay, then we come into territory which is quite what familiar, and all of us must know this. Now, what is this? What is this? This is not a disk. What is this? This is a This could be a conducting hollow sphere, or you can call it, let me call it, you can call it non-conducting or conducting spherical shell. Non-conducting or conducting spherical shell. I hope you understand what do you mean by spherical shell. What do you mean by spherical shell? Hollow sphere. Do we understand this?
Yes, sir.
Or this could also be a conducting sphere. The formula is same for all these three categories. I hope you understand what I'm talking about. A conducting sphere will have electric field, will have charge coming only on the surface. Yes or no?
Yes, sir.
What is the electric field due to this? What is the electric field due to this?
K cube by mod r square.
KQ by? Whenever we have this sphere or shell, we have points. Let me mark it points. One is the center. Then one point is inside the shell or sphere. Then the other point is on the shell or the sphere. Then the other point is outside the shell or the sphere. What is the electric field at the center of the shell or sphere? Huh?
0, sir.
What is the electric field at any point P inside the shell or the sphere? Let's stay. This is not rocket science. You don't know. 0. What is the electric field at any point on the sphere? I don't know. KQ by capital R square. What is the electric field at any point outside the sphere? It is same as a charge
AQX by R cube.
KQ by small r square. That is the electric field outside the sphere. Outside the sphere, it only behaves as a point charge placed at the center. Will you remember it now?
Yes, sir.
Please remember it. Do you know the graph of this one? This graph has come many times in many exams. So remember the graph. And the graph looks like this. Inside the sphere, inside the shell, it is 0. Electric field is maximum on the surface. After that, it goes down like this. You have 2 minutes to draw it.
Completed, sir.
Great. Everyone? Then
Yes, sir.
one thing is remaining. One type of body remains in this. Which type of body remains? We have covered conducting, non-conducting shell. We have covered conducting sphere. One type of body still remains uncovered. Which is that body that remains uncovered?
Solid sphere.
Made up of what? Sphere is always solid, beta. Don't call it solid sphere. Sphere is always solid. Trust me. There is no liquid sphere. Sphere is always solid. You don't have to say solid sphere. It's always solid. Yes, solid sphere in your language. Made up of what? Solid sphere made up of what? A sphere made up of non-conducting material. Because in that case, what will happen? When a sphere is made up of non-conducting material, the charge will also go inside the sphere. We understand this? The charge will also go inside the sphere. So this is non-conducting sphere. Non-conducting sphere. I don't have to say solid because sphere is always solid. Non-conducting sphere. So the charge will also come inside. So we have charge inside the sphere as well. In the previous case, we only had charge on the surface of the sphere. Do we understand this?
Yes, sir.
Now you have to tell me the values. What is electric field at point O? The center. This is O, this is P, this is Q, and this is R. Yes, what is electric field at point P?
0.
0, well done. What is the electric field at point P, which is inside? Distance is small r or x or whatever you want. Yes.
0.
Ah? Not
AQ
0.
by R square.
Hey Bhagwan. KQ into small r divided by r cube. This is the formula that you were saying previously. Inside it is KQ small r by r cube, or you can also call it in this way, which I remember, rho r by 3 epsilon naught. This is the best way to remember this. Rho r by 3 epsilon naught. This is the way I remember it. What is rho here?
Volume charge density.
Charge per unit volume. Great. What is electric field at point Q, which is the surface of the sphere? It is same as Q by 4 pi epsilon naught into R square. What is electric field at point P, which is outside the sphere? Q by 4 pi epsilon naught small r square. You must have seen. You must have seen. You must have seen the graph. Inside the sphere, remember, it is directly proportional to R. That is why it is easier to remember it as rho R by 3 epsilon naught. This is the way I remember it, but you may not remember it in that way. You may remember it in whatever way you understand.
Done, sir.
Sir.
Okay, everyone got this, sir?
Sir.
Then, sir, a question, sir. Coming on your plate, yes, sir.
Sir, 1 minute.
What happened, sir? Okay, I'll give you time. Don't worry. I'm in no hurry. I have to go nowhere. I come to take your class and I'll take your class and then only I'll go anywhere. Don't worry. I have nowhere to go.
Done, sir.
Everyone done, sir?
Yes, sir.
Huh?
Yes, sir.
Then comes a question, sir. And this is the question, sir. You have got this arrangement like this. The radius is R. You have to find the electric field at point P. Best of luck. Don't look at each other's faces. We are yet to discover a technology where we can look at each other's faces and get the answer. That technology does not exist till now. So let's not what? Let's not trust that technology and let us trust our instincts. Answer to this one. Any hope? I'll give you time here. Don't worry. Take your time.
Sir. Lambda by pi epsilon naught r sin theta by 2. Sir,
Yes, but anyone with an answer?
lambda by root 2 pi epsilon naught r.
Very good. You got an answer. Lambda by?
Root 2 pi epsilon naught r.
Lambda by root 2 pi epsilon naught r. That looks good. That is correct. How did you get it? Show me. Tell me. Good. Who got the answer? Tell me.
Electric field due to arc.
Yes, so basically what you got to see here is this one and this one are going to cancel each other out. Yes or no?
Sir,
This one and this one are actually going to add. So you just have to multiply it by 2. You just put the formula for electric field due to a circular arc and you get your answer. What was the formula for circular arc?
lambda by 2 pi epsilon naught r sin theta by 2.
Lambda by 2 pi epsilon naught sin theta by 2. Multiply it
Sir.
by 2. Theta is 90 degrees. And you get your answer. What is the direction of the field? They might ask you the direction because it might be coming in a multiple choice question. So remember, whenever you have a circular arc, the direction is always along the bisector of that arc. You understand this?
Yes, sir.
So always along the bisector of that arc. So remember this. Here in this case, the direction would be at 45 degrees. It would be going like this. That is what you need to remember. Good one. Chalo, this has given me more confidence that I can give you this one. Shall we move on to the next one? Huh?
Sir.
Good, good, good. Then comes this one, my dear friends. Take it away. So here we have an infinite lambda plus lambda. Then we have again infinite, semi-infinite plus lambda near. And then we have minus lambda dung like this. This one looks interesting. Let's see who gets me this one. Huh? Any hope? I think there is hope. The hope is always there. Just be careful, nothing else. Just have to be careful. Just have to be careful. Just have to be careful. I'm waiting patiently for your answers. I have a lot of patience.
Pi by 2 pi epsilon naught into r.
The answer is 0.
Lambda by 2 pi epsilon naught r.
The answer is 0. The answer is 0, my dear friend. How did you get it? Anyone can help me with this? It's hard for me to understand. Can anyone give some insight? How is the answer 0? Answer is 0. That is what the notes say. My notes say that answer is 0. I might have done a mistake in writing or typing, whatever. The typist might have done a mistake in typing, but the answer says 0. My dear friends, how did I get 0? Anyone? The answer is 0. Anyone can tell me how it is 0? Or am I wrong? I'm hardly wrong, but I can be wrong. There could be a mistake in calculation.
E due to positive lambda by 2 pi epsilon naught r.
Yes.
Sin
Answer is not coming 0, na? So I must have done a mistake. Answer is not coming 0, na? Coming
it's
zero?
zero, sir. Yes, sir.
It's coming 0. And then it's correct. My typist and I did not do a mistake in writing the answer and solving it. The answer is 0. How did I get 0? It says, if you just remember how the electric fields were directed, remember, whenever we are talking about electric fields, we are dealing with vectors. So if we just be careful in how we are drawing and the directions, you would be getting the correct answers no matter what. And obviously, you must not do a mistake with the terms that are coming in the equation. So if you just stay on the right track, you would be able to do it.
Sir, E due to positive charge is lambda by 2 pi epsilon naught r into sin 90.
Right. So basically, let me not confuse this so further. I just wanted you to imagine it. That's the only reason, beta. So let me just do it one by one. So let us talk about this pink wire, and I will draw everything by pink. So this pink wire will have two electric fields, one going like this and one going like this, right? The value of this is lambda by 4 pi epsilon naught. Do we understand this? See, I might not even write anything and I probably would get the answer. Now, let me draw this field of green wire. Green wire is going like this and going like this. Yes or no? Same. Lambda by 4 pi epsilon naught, right? So, this and this cancel. Lambda by 4 pi epsilon naught and lambda by 4 pi epsilon naught gets added up. We get lambda by 2 pi epsilon naught in this direction. But then I have a negative charge. So this negative charge, let me make it this one, pink, blue. This negative charge is going to produce which is lit direction. Now this is semicircle. So lambda, so theta is 180 degrees. So 180 by 2 is 90 degrees. And you put the values. It is lambda by 2 pi epsilon naught into sine of 90. So this field and this field will cancel each other out and we will end up with 0. Do we understand it? Or this has gone above it saying bye bye, bye bye. I'm going, don't worry about me. We understand this, everyone? One class has disappeared. The other class, we understand this?
Yes, sir.
Okay, sir. Then, sir, this question is a brother of that question, sir. So if you understand the younger brother, then this older brother comes. And this older brother, now in that younger brother, one charge was minus, but here in this older brother, all charges are positive. Positive, 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 and positive. What is the answer for this one?
Lambda by 2 pi epsilon naught r.
And the answer is 0. It is again 0. The lambda, the answer is still 0. How did I get 0 again? See, that's what I'm saying, beta. Please be careful while we are doing questions of this nature, because if you are just a bit careless, the thing will disappear. Now, if I talk about this pink electric field, one electric field will be going like this, and the other electric field will be going like this. If I talk about this green one electric field will be going like this, one electric field will be going like this. I'm not writing any values here. See, Without writing any values, you can do dung, dung. It get cancelled. Lambda by 4 plus lambda by 4 becomes lambda by 2. Because of this positive charge, let me color it blue. It will go like this. Lambda by 2. This cancels this. We end up with 0. We understand this, or this has gone up our saying bye bye, bye bye, don't worry about me. I'm gone. Tata. Bye bye. Shall we move ahead in life? Life has to move on.
Yes, sir.
Okay, then we have this infinite sheet. Everyone knows the formula of this infinite sheet? Yes or no? Everyone knows the formula of infinite sheet? Yes or no? Everyone knows the formula of infinite sheet? Yes or no? Not getting any answers. That means you don't know.
No, sir.
Infinite sheet you have not done, sigma by 2 epsilon naught. Okay, before going on to infinite sheet, I've got this one also. So you just note this one down. This is a hollow hemispherical cup. Hemisphere, hollow hemisphere. Half shell. This half shell has a surface charge density sigma. This half shell has a surface charge density sigma. What will be the direction of electric field at this point? First of all, tell me this. What will be the direction of electric field at this point? What will be the direction of field at this point? You don't know? So just write it down. The direction of field will be like this. Again, if you get a part of this shell.
Sir.
Yes, beta. Yes, what happened? Everything's okay?
Sir. So slide, sir, and explain.
Yes, beta.
Can you show previous question, sir?
Okay, can I show the previous question? Yes,
And-
can't I show the question? I have the question in my hands. So this was
And
the
explain,
question.
sir, once.
This was the question. We had everything like this. We had everything like this.
Before this.
All of the charges were positive, 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 positive,
Sir,
positive.
before this.
Not this one, the previous one. They
Yes,
are
sir.
same. They are same. This one and this one both are same.
Okay, sir.
This one and this one both are same. So I explain this one or this one. Both are same.
Okay, sir.
No, I'll explain this one. So if I call this field as pink one, this pink field, one field will go here, the other field will go here, lambda by 4 pi epsilon naught. Yes or no?
Yes, sir.
If I call this one as the green one, One green will go here and one green will go here, lambda by 4 pi epsilon naught. This green and this green, this pink will cancel. Yes or no?
Yes,
Yes
sir.
or no? Lambda by 4 plus lambda by 4 will become lambda by 2. Yes or no? So lambda by 2 will be going in the right hand side. Now look at this blue one. This blue is a semicircle and it's a negative semicircle. So electric field will be coming towards the semicircle. Theta is 180. 180 by 2 is 90. Lambda by 2 pi epsilon naught into 90. This total field will cancel these two fields put together. Yes or no?
Yes, sir.
So the answer is
0.
0. Now, this is the brother of this one. Take 2 minutes and solve it.
Sir, screen has stuck.
Now there.
Yes, sir. Okay, sir. Sir, answer is 0.
Answer for this one is also
0.
0. Anyone understands this? Yes or no?
Yes, sir.
Then just note the answer for this one. This is a hemispherical shell, half shell. Hemispherical half shell. The electric field due to half shell will go in this direction. Just remember the formula. The formula for this is sigma by 4 epsilon naught. We'll also create a uniform field at this point. Sigma by 4 epsilon naught. It is the electric field at the center of this half shell. Remember this and don't forget this. See, in the examination hall, you will not get enough time to calculate it. And again, as I said, if you do a simple mistake, you're done. So just have to remember it. Okay. We got this. Shall we move ahead in life? Yes or no? And the next thing that you will write is electric field due to an infinite sheet. And we'll do a couple of questions on this because we will be needing this. Write the heading electric field due to infinite sheet. Do you know the electric field due to infinite sheet? Someone told me no.
Sigma by 2 pi epsilon naught.
Sigma by 2 pi epsilon naught. An infinite sheet actually looks like this. This is the broader view that I am going to show. A very big view, but doesn't matter. I hope you understand this. I will also tell you the general answer. I would have written that general answer somewhere. I'll show you the general answer also. Infinite sheet means this. Infinite sheet means this. Infinite sheet means this. It is infinite in this dimension. It is infinite in this dimension. Do we understand this? This is an infinite sheet. Now, any sheet can be infinite depending on the distance. If the point is very near to the sheet, that becomes an infinite sheet. So infinite is just a word. Infinite sheet means for this wall, if I get very close to the wall, that becomes an infinite sheet. Do we understand this? This phone which just rang. Oops. This phone which just rang. If I get too close to this phone is an infinite sheet. Do we understand this? Infinite sheet. The formula for infinite sheet is sigma by what?
Epsilon naught.
Sigma by 2 epsilon naught. Remember this. Everyone remembers this?
Yes.
Then there on this infinite sheet, there are a lot of problems that can be done. So we'll do a couple and then we will move ahead because I don't know. I feel that you can get a problem. Again, you will not get a problem in JEE Main. You probably get a problem in JEE Advanced, and this is the first problem. I don't know whether you have done it or not. I have done a similar problem where I told you that it is nothing but a projectile motion. This is the total projectile motion here. An infinite sheet of charge density plus sigma is lying on the horizontal plane. A plane particle having charge minus q. Mass m is projected with a velocity u, making an angle. Find all these things. You don't have to find it. If you can just apply your common sense, you will get the answer and tell me the results. I'll give you 2 minutes still to do it. So, my dear friends, what is the answer? Eh? No one has any answers. Huh? Everyone is sitting and chilling out. This is the time to chill out. Let's chill out, boys. This is not the time for you to chill out, my dear friends. If you chill out now, it is cold outside here. May not be in Hyderabad, but it is cold outside. Everyone can go out and he will get chilled. But this is not the time for you to chill out. This is the time for you to warm up, because your exam is coming. You need to warm up. So don't chill out. Give me the answer fast, or tell me, sir, we don't know. Help us, sir. And say SOS, SOS, SOS. You know the meaning of SOS? Huh? Are? Do you know the meaning of SOS? No one knows the meaning of SOS. What is SOS? What is SOS?
Don't know, sir.
No one knows. I was a marine engineer some eons ago. Eons ago, I was a marine engineer. I have forgotten marine engineering, but I was a marine engineer basically. SOS means save our
Sir.
souls.
4
And this
pi
is a
epsilon
distress
naught
message.
4 sin theta.
Yes?
4 pi epsilon naught E sin theta by lambda.
Can't hear anything. But SOS means save our souls. And save our souls means we are dying. When a ship is
By
sinking.
epsilon naught U sin theta by lambda.
Now see, as soon as I said SOS, I start getting some answers. Answers may be right, answers may be wrong, doesn't matter. Answer should be there, right or wrong. So, how do you do it? Again, this is a revision of your what? This is a revision of your motion in 2D. What was the time period of this gentleman in motion in 2D? Huh? What was the time period? If I remember correctly, I've just taught some students. The time period was 2u sin theta by g. Yes or no? Yes or no? You just have to replace this
Yes,
g.
sir.
Yes, sir. You just have to replace this g by g effective. And what is this g effective? It is q into e by m. Q is the charge. It is downward only force. Q is the charge. Electric field is sigma by 2 epsilon naught divided by m. So you just put ding, 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 this here, and you get the value of your time of flight. We understand this? And just put it and get the answer. What about the maximum height? H max. It was u square sine square theta by 2g. Yes or no?
Yes, sir.
In place of g, just put that value. To get the value of range, it was u square sine 2 theta by g. In place of g, just put that value and we are done. Got this?
Yes, sir.
Now, this is a question that we did in the previous class. And I know all of you are Gajnis, so you will not remember. So I'm giving it again, and I hope that you can give the answer now at least. A block having mass m and charge q is resting on a frictionless plane. He's chilling out like you guys at a distance d from a fixed infinite non-conducting sheet of charge density as shown in the figure. So I have to also show you the figure. No, that's not fair. But since it's given shown in the figure, so I have to show you the figure. So here comes the figure. Dan, dan. There's a movie called Phata Poster Nikla Hero. It's a dialect from a movie when I was probably younger than you. Hero Hiralal was the name of the movie. And in this movie, there was a character, there was an actor called Nasiruddin Shah. And he used to, when he made an entry, that was a poster that was being torn and he came out of that. And that's why it came the dialogue, Phata Poster Nikla Hero. So here is the hero. You have to find out the time period of these oscillations. We have already done this question. Let's see how quickly you can give the answer for this one. And I can see people turning pages. So a block having mass m and charge q is resting on a frictionless surface at a distance d from a fixed non-conducting infinite sheet of uniform charge density minus sigma is shown in the figure. Assuming that the collision of the block with the sheet is perfectly elastic, find the time period of oscillatory motion of the block. Is it SHM? It is not SHM, I told you that. What is the answer, my dear friends? And I wait. It is already 5:29 and only 30 seconds are left for the class to get over. 29, 28, 27, 26, 25, 24.
Root over 2md by QE.
Yes, I have an answer. Yes, what is the answer? Time period? I can't hear you. Two times? Two times I can understand. The answer is this one. If you are giving me this answer, then congratulations for not becoming Ghazni and for remaining normal human being. So well done. If you have not become Ghazni, good. Why I'm doing so many questions? Because I just feel from the bottom of my heart that such question can definitely come. These are not questions for JEE Main. These are questions for JEE Advanced. Because this question has two parts. So they will give you this condition and then they give you the motion is SHM, the motion is not SHM. The time period is this, the time period is this. So it becomes a multiple choice question. And what are the most difficult questions asked in a JEE? They are the multiple choice ones. And those are the ones that you must stay away from. Because even if you mark one option wrong, you get minus. And once you get minus, your entire effort in plus goes down the drain. So JEE Advanced, stay away from multiple choice. Unless and until you know it, only mark that option which you know. Else don't touch them. Because these are the questions that gives the maximum negative marks. And these are the questions that are the most difficult one in the JEE. That's my honest opinion. Okay, with this, and we have taken a lot of steps today. We have almost done with electric field, but there are a couple of questions that I would like to do more. Because even if I don't do it now, I will have to do it 3 class afterwards. So why not do it now when everything is fresh in our mind? So Probably in the next class, we will be done with electric field, and then we'll move on to more greener postures. Probably we'll move on to your favorite Gauss law. Gauss law is not completed, right? No, Gauss law is also completed.
Yes, sir.
Completed or not completed?
Not completed, sir.
Chalo, we'll do something new tomorrow at least, and we will try to solve as many questions as possible. Remember, these are the questions that you have to insist on. You don't have to look anywhere else. If you want to do SC Verma, if you have time, then only do it. Otherwise, don't do it.
Sir,
Yes,
do we have class tomorrow?
I think so. Yes. I don't know. I'll probably get a confirmation in the night, but you will have class tomorrow. If you have class tomorrow, we will be moving ahead with thermodynamics. We will be doing internal energy and thermodynamic process tomorrow in the class. And maybe in 1 or 2 class, we will be done with entire thermodynamics. And then we'll move on to something else from your last year's topic. Yes. Anything else?
Nothing, sir. Thank you.
Concentrate on what sheets I have sent you. I've sent you the sheet of electrostatic as well. Just concentrate on those questions and on those questions which I am doing in the class. If you get extra time, then only you look for something else. Otherwise, it is more than enough that you will ever require to clear any exam in on this universe or any other known or unknown universe. Okay?
Yeah.
Take care. God bless all of you. Bye bye.